Okay, so just like when we did graphing lines, we had standard form and then we had slope-intercept form. Standard form, not so easy to graph, but slope-intercept form, you just find the slope, you find your beginning point, you find the slope, you graph, and it was easy. Same thing with quadratic equations. We've done the standard form, ax squared plus bx plus c. Now we're going to do the vertex form. Looks complicated, but super easy to graph. So first we have to know what that vertex form is. So it's y equals a times x minus h squared plus k. Now, I want you to see here, h represents the horizontal shift. So it goes left and right. It's that x, it's that x value because you go left and right on your graph. Those are your x values. So h represents your x value. Notice it's the opposite of whatever this is. So if this is a negative h, that means your x value is going to be located h. It's the opposite, okay? So negative h, therefore it'd be positive. The k represents that vertical shift, and you're shifting on the y-axis. So you go up and down on the y. So k, regular k, because it's not in parentheses, represents that vertical shift. So hk is the vertex, and h, remember, x equals h is the axis of symmetry. That vertex will always be on that axis of symmetry because the vertex is either maximum point or the minimum point. So h has to be the same as the axis of symmetry. So if you look at number 1, my axis of symmetry, let's do the vertex first because we did it first up here. But remember, my vertex is the opposite of positive 4, which makes it negative 4. And my k value is negative 2. So there is my vertex. And then my axis of symmetry is always located where that vertex is. So x equals negative 4. Remember, you have to have that x equals because axis of symmetry represents a line. So let's jump down to number 3. So that axis of symmetry is x equals the opposite of negative 5, which is 5. And so my vertex is 5, comma, negative 4. Okay? Look over here at number 2. My x value, that horizontal, is going to be x equals positive 3. So 3 is my x value. There is no k. So what value represents unknown or not there is going to be 0. So my vertex is 3, 0. Look down here. I don't have anything in parentheses. If you don't have anything in parentheses, your x value is going to be 0. And my k value is positive 3. Therefore, my axis of symmetry is x equals 0. It's always the same as that x value, okay? So hopefully that should be pretty easy. Let's take a look at graphing now. We're going to do kind of what we did. We're going to use the graphing calculator, except we still need to find the axis of symmetry. So I'm still going to find the axis of symmetry. I'm still going to find the vertex. Then I'm going to let my calculator do the work. So that axis of symmetry is the opposite of positive 2, which is x equals negative 2. My vertex is negative 2, 7. I still want to put that vertex smack dab in the middle, negative 2, 7. So I'm going to go over here. I'm going to locate negative 2, 7. And then my axis of symmetry is negative 2. Now, look at this equation. That leading value is negative, so that means my parabola is going to go down like a frown. Okay, that's what that negative means. It's going to go down. So now let's use my handy-dandy calculator. So I go to y equals, remember that where that y equals button is, and then I'm going to type in exactly what I see. Remember, you have to type in a negative there, so negative is located right by that decimal. Open parenthesis, parenthesis is above your 8, and then I'm going to type in x plus 2, close parenthesis, and that squared button, remember, is diagonal from that 7. And then I'm going to put plus 7. And my end goal is to graph it, but right now I want to see that table of values, so I'm going to go to second graph. I'm going to locate my vertex. I know it's negative 2, 7, and I'm going to do just what I did yesterday. 2 points above, use that arrow key, and 2 points below. I'm going to plot those points. -3, 6, -4, 3. And look, I don't even have to look at those because I'm going to do the axis of symmetry, remember, splits it in half. So if you go 1 unit over here, you go 1 unit over here, 2 units here, 2 units here. And then I'm going to draw my parabola. That's what it looks like. How far left and how far right does it go? Forever, so it's all real numbers. And my range, it's going to go all the way up to 7, but it will never go above. It's going to go below 7. So y is less than or equal to 7. So just what we did yesterday, except now it's in vertex form. So I think that's pretty easy. So let's go and do transformations. Talk about transformations. So what is a transformation? All a transformation is it's just literally moving and changing that parent graph. So I'm going to show you what a parent graph looks like. And remember, we did this with linear equations. In linear equations, we said if you graphed y equals x, notice what happens. In y equals x, my beginning point is 0, and my slope is 1. So that means I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and then I can graph it. And it graphs a line because that's linear. Now, I can change this parent graph, and this line, I can move it up, which is the vertical shift, just like a parabola. And when you move it up and down, it's this beginning point. -1, you would start at -1, and then your slope up 1 over 1, up 1 over 1, and it would literally move this graph down 1 unit, right? You can also move it up. If you moved it up 4 units, you would literally take this line and move it up 4 units, that vertical shift. Same thing with the parabola, okay? We're shifting the parent graph. Now, in a line, you can move the slope up and back. You know, it can get steeper, it can get more not as steep, so you go slower on a mountain. And it's the same thing when we have a parent graph of the quadratic equation. So the most simplistic quadratic equation is going to be y equals x squared. And when we have y equals x squared, here's where we have that parent graph right here. And this is known as the parent graph. A transformation is a change to the size or position of a figure. So we already said that that h value is that horizontal shift and that k value is that vertical shift. We know that if this leading coefficient is positive, he's going to go up, and if it's negative, it's going to go down like a frown. We already know that. So there's a lot of information we know here. So if I still want to find my vertex. So it's going to be -2, 0. And I'm going to let the calculator do my work. But watch what happens here. I can take these values right here. Okay, so those intersect the graph perfectly. And I know that it is shifting 2 units to my left because it's the opposite. You would think positive, but remember it's the negative. So we're going to shift. All these points are located on the parent graph. If you were to literally draw a graph, you know, and I graphed y equals x squared, when x is 0, 0 squared, y is 0. Okay? When x is 1, 1 squared is 1. When x is -1, -1 squared is still +1. When x is 2, 2 squared is 4. And when x is -2, -2 squared is 4. Okay? So this is the points to that parent graph. Okay? That's the points to the parent graph. And I just highlighted them. I highlighted 0, 0. I highlighted -1, 1, -2, 4, 1, 1, and 2, 4. Hope you're with me on that. Now, I know this represents a horizontal shift left. So what that means is these points are all going to shift to the left 2 units. I can shift this guy 2 units. I can shift this guy 2 units. I can shift this guy to the left 2 units. I can shift this guy to the left 2 units, and I can shift this guy to the left 2 units. And then I draw my points. You see how I did that? Okay. And now I'm just going to name those new points. So I have -2, 0. I have -3, 1. I have -4, 4. And then I have -1, 1. And I have 0, 4. And this blue graph then represents that shifting, that changing position of the parent graph. I literally shifted it 2 units to the left. So what would I say on my transformation? All you got to tell me is you shifted left 2 units. That's all it did. Okay, let's do another example together. I think I'm going to do another example together. All right, so let's look at number 8. There's nothing going on with my horizontal shift. The only thing that is shifting, it's going vertically 5 units. So I know that my vertex is going to be located at 0, 5. I know that because vertex form, right? Now, let's do what we did in the last example. I'm just highlighting those parent graph points. 0, 0, -1, 1, -1, 1, -2, 4, and 2, 4. That's my parent graph. That's my original. Well, what happens to these points in a graph given like this? All it's doing is it's shifting everything up 5 units. So literally, you are lifting all these points up 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now you've got this graph, and we're just going to name the points. We've already named 0, 5. We know it's in vertex form. And here I have -1, 6, -2, 9. And then over here I have 1, 6, and I have 2, 9. So I have filled in my table, and I've looked at the shift. And all we did is we shifted vertically up 5 units. Okay, that's all we did. Let's do another one. Let's go down here to 10. Okay, look at 10. All right, we got a lot of things going on, but it's okay. It's not too bad for us. First, I'm going to highlight these points. -2, 4. Now, the most important one is I know that it's going down. So the first thing I'm going to do is I'm going to shift it down. I'm going to reflect it. So that's going to be the same, and I'm just reflecting it over the x-axis. So 4 units, 4 units, 4 units, 4 units. Do you see how I'm getting this graph? If I just literally flipped it, I reflected it, the negative over. Okay, now what I'm going to do is I'm still going to plot these points right here. Those are my new plots. If it's flipped negatively, you want to go ahead and label that points because these are easier to work with. Because right now, we know it's a horizontal shift of +4 and a vertical shift of +1. So that means each of these points, I'm going to go to the right 4 units and up 1. To the right 4 units and up 1. So I'm going to the right 4 units, up 1. This point right here. To the right 4 units, 1, 2, 3, 4, up 1. To the right 4 units, 1, 2, 3, 4, up 1. To the right 4 units, 1, 2, 3, 4, up 1. And to the right 4 units, 1, 2, 3, 4, up 1. And there, this green is my new table of value points. So we already know that the vertex is going to be 4, 1. We know that. And now I'm just going to plot my other points. So here's my vertex, plotted 4, 1. So this guy is 3, 0. This guy is 2, 1, 2, 3, -4. 2, negative 4. This guy to the right is going to be 5, 0. And this guy is going to be 6. I'm sorry. I needed this point of negative 3. My bad. That's negative 3. And then 6, negative 3. So that's my new transformation. So what did we do? We reflected over the x-axis. I cannot spell. We shifted horizontal 4 units to the right, and then we shifted 1 unit up. So we had 3 things going on: reflected, horizontal shift, vertical shift. Okay? All right, so those are the examples there. And now we're going to put it all together. And let that catch up. All right, so what do we know that we've already talked about? Well, we've already talked about all this. H is the horizontal shift. Positive means it shifts to the left. Remember, it's opposite. And negative shifts to the opposite direction, which is the right. K is the vertical shift. Positive shifts up. Negative shifts down. If A is negative, the function is reflected across the x-axis. And if A, okay, this is the one that we didn't do because you don't have to do this one by hand. But when A value is greater than 1, it represents a stretch. Because this value, I'll show you in a second, it's going to stretch that graph, okay? When A is less than 1, so less than 1, greater than 0, it's a compression. And a compression is like it's taking that parent graph and it makes it fat. It's like compressed, which spreads it out this way. A stretch makes it go up a lot. So here's what that means. When you have something that looks like this, this value is less than 1, so that's a compression. It's going to make it fat. It's going to go wide. That's a compression. This on number 11, this 3, it's going to stretch it out. It starts here, and eventually it's going to look like this. It's a stretch. Okay, so stretch versus compression. So now, when we write equations, this is fun. I love this. It's like a puzzle. Okay, if it's translated 2 units to the right, so we know it's y equals, so we're taking our parent graph, and we're going to translate it to the right. So it's going to be y equals x. To the right is positive, so that means it's going to be negative 2. Don't forget to square it. Squaring it creates that parabola. So don't get lazy. You got to square it. Number 15, translated 3 units to the left. So left and right means x-axis, and 4 units down, that's your y-axis. So y equals, to the left is negative, so it's going to be x plus 3 squared, and 4 units down, minus 4. Look at number 17. Oh, we have a reflection. So it's negative, reflected over the x, then translated 3 units down. So nothing's happening on the horizontal shift. So I have x squared, but it's 3 units down. Okay? Look at number 19. Vertically compressed by a factor of 1/3. That's easy because it kind of tells you what to do. Vertically compressed by a factor of 1/3. Then translated 8 units up. So nothing's happening to the left and right, but it's 8 units up, so it's plus 8. Okay? So there it is for transformations. Come see me if you're struggling.